Hey guys, so here we are with the test review. So the first question, 21 pounds of bananas cost $78. How much would 29 pounds cost? We're going to use our units here to help us set a proportion. Here we have 21 pounds and 29 pounds, and here we have $78. So since 21 pounds cost $78, we're going to set this equal to 29 pounds. Now, pounds are both on the top, and we want to know how many dollars 29 pounds costs. Okay, if we cross multiply and divide, we'll find that x equals 107 and 714 thousandths. And we need to round to the nearest hundredth, especially since we're talking about money here. So this would round to $107.71. Okay, if you need to review the rules of rounding, you can Google that, or if you need to review how to solve a proportion using cross multiplication, you can Google that as well. Alright, number 2, a car travels 276 miles on 28 gallons of gasoline. How far can it travel on 52 gallons? So here we go again. We're going to set up a proportion, and we're going to let our units guide where we're putting things. So if we put 267 miles on top here, and 28 gallons of gasoline down here, we're going to have to do the same on the second ratio. Miles is on top, gallons is on bottom. Okay, we find out that x equals 495 and 857 thousandths. And if we're rounding to the nearest hundredth, this would round to 495 and 86 hundredths gallons of gas. Alright, number 3, there are 756 pupils in a school. The ratio of boys to girls is 4 to 5. How many boys are in this school? How many girls are in this school? Okay, so we have a couple of different units here. We have 756, and this is the total amount. We have 4 boys for every 5 girls. Okay, so you might be tempted to do 4 over 5 equals x over 756. That would work. The foolproof method, the way I like to do it is I'll see 4 to 5 is my ratio of boys to girls. That means for every 4 boys, or I'm sorry, every 9 total people, there are 4 boys. And we can set this equal to x boys over 756 total people. Now you could see my units do line up. Okay, the trick here was saying for if there's 4 boys to every 5 girls, that means out of every 9 students, 4 of them are boys. Okay, cross multiply and divide. We'll find out that x equals 336, and this is how many boys there are in the building. All we have to do is subtract 756 and 336, and we will find out how many girls there are in the building. There are 420 girls. Write that again. Okay? Number 4. A jar is filled with pennies and nickels in the ratio of 4 to 3, pennies to nickels. There are 30 nickels in the jar. How many coins are there in all? Okay, well, we have 4 pennies to 3 nickels, and there are 30 nickels. So we can say that out of every 7 coins, 3 are nickels, and this is out of every 7 total, because 3 plus 4 is 7, 7 total. Now we know there are 30 nickels, and we want to see how many coins there are total. Cross multiply and divide here, and you will get that there are 70 coins total. X equals 70 coins total. Okay, Preston drove to his new college and then back home. Round trip he traveled 210 miles. Preston drives a Honda Civic and gets 30 miles for every gallon of gas. If Preston needs to make 12 round trips a year, how much will it cost him in gas, assuming that the price of gas stays at $3.25 a gallon? Okay, so there's a couple of things we need to know here to start off. How many miles does Preston drive in a year? And then how much or how many gallons of gas does he use in a year? So first let's figure out how many miles he drives in a year. So round trip, one trip is 210 miles. And we're going to set this equal to 12 trips is, we don't know how many miles. Okay, so we'll solve for x here and we'll find out that x equals 2,520 miles. So that's how many miles he drives in 1 year. Okay, now we need to figure out how many gallons of gas he uses in 2,520 miles. Well, we know that, thanks to that right there, he goes 30 miles for every 1 gallon of gas, and we want to know how many gallons of gas he's going to use in 2,520 miles. Okay, we solve for x again, we find that x equals 84 gallons of gas. Well, now that we know he uses 84 gallons of gas, we can multiply that by $3.25 per gallon, and we'll find out that it costs Preston $273 to drive back and forth from college to home. All right, number 6. Oscar loved cheeseburgers. He enters a 24-hour cheeseburger eating contest. During the contest, Oscar eats a cheeseburger every 10 minutes. How many cheeseburgers will he eat during the entire contest? Okay, so we see 24-hour cheeseburger eating contest, and that he eats a cheeseburger every 10 minutes. What we need to do is we have too many units. We have 24 hours, we have 10 minutes, and we have 1 cheeseburger, because that's how many cheeseburgers he eats in 10 minutes. So what we need to do is we need to convert hours to minutes. Okay, and there's 1,444 minutes in 24 hours. Now that we have everything in the same unit that we need it to be, we can set up a proportion. If he eats 1 cheeseburger every 10 minutes, we want to know how many cheeseburgers he's going to eat in 1,440 minutes. Let's fix that. Okay, solve for x here, and we're going to find out that in 24 hours, Oscar eats 144 cheeseburgers. Okay, number 7. A dentist sees a patient every 15 minutes. He works an average 50 hours per week. How many patients does he see in a year? He takes 3 weeks of vacation. Okay, so if he sees a patient every 15 minutes, and we know he works 50 hours per week, once again we have the same issue where we have 3 different units. Now we could take hours, 50 hours, and convert this to minutes, and now we have things in the same unit again, so we can work with this. So if he sees 1 patient every 15 minutes, and we want to know how many patients he will see in 3,000 minutes. Okay, cross multiply, divide, solve for x, and we'll see that in 3,000 minutes he sees 200 patients. Okay, but that's not what the question is asking. The question is asking how many patients does he see in a year. And not to forget that he takes 3 weeks of vacation. Okay, now if you remember that there are 52 weeks in 1 year, and if he goes on vacation for 3 of those, he's only working 49 weeks. So we have to multiply 200 patients a week times 49 weeks, and we will see that he sees 9,800 patients per year. Okay, number 8. A $500 TV was put on sale for 25% off. It didn't sell, so the price was lowered an additional percent off the sale price, making the new price $312. What was the second percent discount that was given? Okay, so we have 2 proportions we're going to need to set up here. We're going to have to find out what the amount taken off the first discount was, and then we could find out the percent taken off for the second discount. Okay, so if we set our proportion up here for this part right here, we have 25 over 100, because that's the percent always goes over 100. Now we have to decide whether or not 500 is the whole or a part. And 500 is the whole price of the TV, so 500 goes on the bottom. And we're left with, we have to find out the part. Okay, cross multiply, divide, we find out that X equals $125. But this isn't how much you pay for the TV. This is how much the TV is discounted. So we have to take $500 and subtract it from 125. So $375 is the discounted price of the TV after the first discount. So we know now that it didn't sell, so the price was lowered an additional percent off, making the new price $312. So we want to know at this point what the percent decrease is for the second TV, for the second discount. So we could just use our percent decrease formula here. Times 100, and we will find out what the percent decrease is. Okay, and if you figured it out, you would see that the second percent decrease was 16.8%. Okay, in question number 8, what was the total percent discount received on the TV? Well, the original price of the TV was $500, and we found, or the problem even told us, that the second discounted price was $312. So this problem is really just this simple. So we do 500 minus 312, divide that by 500, multiply that by 100, and we get the total discount or total percent decrease was 37 6/10%. Okay, number 10. Chris's pay went from $20 an hour to $25 an hour after his first evaluation. After his second evaluation, his pay was raised to $33 an hour. When comparing the percent increases, what percent more was the first raise than the second? So we have to make a comparison here. The gentleman received 2 different raises, and we need to see which raise was bigger. So we want to find which percent increase was bigger. Okay? So if we look at the first percent increase, we could set it up like this. 25 minus 20 over the original, which was 20. And this equals a 25% pay increase. Now we want to see what the percent increase was for his second pay raise. So 33 minus 25, because that's what he's getting paid now, over 25 times 100 equals 32%. Okay, and now we can see that his pay raise was 32% the second time, and the first time his pay raise was 25%. So the second one was 7% bigger. Okay, that ends the first part of this video. You should see the second video being online in a couple of minutes.